Hi friends, welcome to Marine Shouters. This is the third tutorial of the how to read electrical circuit diagram. So now we are covering the electrical components and how it represented. So the next component is the thermal overload relay. You know the thermal overload relay why we are using in the circuit when the motor, for example, when the motor windings, it will take the huge starting current and all, no? The winding takes the current and the rotating magnetic field will produce, and that will in turn rotate the rotor in case of an induction motor. So if the current is too much, whenever the current carrying when a current carrying conductor, it will produce magnetic field. Also, the Joule's effect, it will also produce the heating effect. So the similar way the winding carries current, so it will produce heat. So if it is a heavy current like a massive current, so it will produce more heat that will cause damage to the insulation. To prevent that, for a certain current, means for a certain extent, to prevent this, we are using the thermal overload relay in a circuit. These are the practical view of the thermal overload relay, how it looks on different company. Photos are here. So we will just cover how it simply works. This is the thermal overload relay, how it looks inside. So basically a bimetallic strip. Here the bimetallic strip, three numbers are there because it's three phase. So each phase windings there is a current coil. The current coil is there, so the current will pass through like this and like this. Whenever the more current, it will heat up the element. The bimetallic strip, it will bend. The two different metals are there, it will bend of different thermal coefficient of expansion. So thermal coefficient of expansion is different for these two elements. So which one is more, it will bend towards that, and the tripping mechanism will, the NC, the normally closed, will get open and it will open the circuit. That's how it works. I just roughly said. If you need more, you just come and me, I will make it a separate video how it works. So our basic idea is, means for in this video we are not talking about the working, we are only concerned about the representation in the circuit. So mostly the number would be according to the IEC or NC. The number is 51. Whenever you see the 51 in the circuit, it will represent it like this, and on the top you already represents the thermal overload relay. Okay, and you see there is a stop button is there or a reset button is there, and this normally the thermal overload relay, how it represents, it represents like this in the circuit, like our OCR, the overcurrent relay, same like. But here we have a manual reset. The contact we will also find here, it is in the circuit, the main line, and there is a contact is there, thermal oil contact reset. So it will represent it like this. This is normally open. You see the line is on the top, and the cross, which is cross is there, it will also call the thermal overload contact Load contact reset. This is a reset, normally open. If it is normally closed, it will look like this. This is normally closed, the reset button for thermal overload relay. Okay guys, this is the circuit diagram we shown. We are the steady case, our steady case circuit diagram. Okay, now you know the different components. Like, see, our component is here 51. This is the thermal overload relay, or it may be overcurrent relay, anything. But here there is no reset button. You can find out here because there is no 51 that close. The contact like this, either like this or like this. So it's not like that, but it's the relay is represented like this. Okay, anyway, the 51, you know, now you know the thermal overload relay is 51. And earlier video we already see this is the MCCB or MCB, and this is the main contact of the main contactor, coil of the main contactor, and auxiliary contact of the main contactor. And yeah, and now you know the thermal overload relay also. Okay guys, I think you got my point, and you just try to draw and remember this thing. And okay, anyway, thank you. I'm stopping here, and on next video we will see the other component. Thank you guys. Bye bye.